Before existence as we know it, before the very concept of before could even apply, there was nothing. No time, no space, just an absolute, infinite nothing. A void so complete it defies comprehension. It was a state of pure potential, pregnant with the possibility of everything that was to come. Then, in a single instant, everything began. The Big Bang. The singularity burst forth, an event of unimaginable power and scope. Not an explosion space like a firework in the night, but the birth and expansion of space itself. Space, time, matter, and energy all erupting into existence simultaneously. All matter and energy erupted from a point of infinite density and temperature. A singularity beyond our current understanding of physics. In the first split second, the fundamental forces, gravity, the force that binds the cosmos, electromagnetism, governing light and chemical interactions, strong and weak nuclear, separated, each force taking on its distinct role in the unfolding drama of the universe. The universe was a blinding hot plasma, an opaque soup of energy and particles. Light itself was trapped, unable to escape the dense, energetic environment. Photons bounced endlessly off free electrons, unable to travel any significant distance. For nearly 400,000 years, a cosmic eternity in those early moments, the universe expanded and cooled, the relentless expansion stretching the fabric of space-time. It remained a dense, swirling fog of particles and energy, a primordial soup on a cosmic scale. Protons and neutrons formed, the building blocks of atomic nuclei, but atoms could not yet exist in a stable form. The energy was still too high, the environment too chaotic. Electrons roamed free, unbound to any nucleus, scattering photons and keeping the universe opaque, a light-tight seal on the early cosmos. Then, as the universe cooled, as the relentless expansion continued its work to about 3,000 degrees Celsius, a temperature still incredibly hot by human standards, electrons joined protons and neutrons, a monumental union in the history of the universe, to form the first atoms, hydrogen, the simplest and most abundant element, and helium. The primordial elements forged in the crucible of the early universe. This event, called recombination, though perhaps combination would be more accurate, changed everything. It was a turning point, a cosmic phase transition of immense significance. Suddenly, light could travel freely. No longer constantly scattered, the universe became transparent. The cosmic fog lifted, revealing the vastness of space. The first light streamed out unimpeded, carrying a snapshot of the infant cosmos, a baby picture of the universe. This ancient glow, a faint whisper from the dawn of time, stretched by time, its wavelengths elongated by the expansion of the universe, is the cosmic microwave background, the CMB. It is the oldest light in existence, the most ancient photons our instruments can detect, a silent echo of creation, a testament to the Big Bang. If we could see microwaves, if our eyes were sensitive to that part of the electromagnetic spectrum, the night sky would glow, not with the light of stars, but with something far more ancient, with this afterglow, a constant, pervasive reminder of the universe's fiery birth. The universe had taken its first step, a crucial transition in its long and ongoing evolution, from energy to matter. The raw ingredients for everything that would follow were now in place. The stage was set, the fundamental laws of physics established, but the theater was still dark. The actors, the stars and galaxies, had not yet made their entrance. The age of light had begun, the universe illuminated by the afterglow of the Big Bang, but the age of stars was yet to come. The universe was waiting for the next act. Imagine that first light spreading out in all directions, filling all of space, a uniform, all-encompassing radiation, a universe of simple atoms, hydrogen and helium, the raw materials for future stars drifting in the dark, suspended in the vast emptiness, awaiting the forces that would shape their destiny, waiting for gravity to do its work, for the first stars to ignite, for the universe to truly begin its story. After the initial burst of light following the Big Bang, the universe plunged into what we call the cosmic dark ages. It was a period of profound quiet and unseen development, a necessary prelude to the grand cosmic symphony that was to come. For hundreds of millions of years, there was only darkness. Imagine an endless expanse devoid of any visible light, any shining stars or any galaxies. No stars, no new light to pierce the inky blackness. It was a time of cosmic infancy, a period of gestation before the universe truly began to shine. The universe was filled with silent, vast clouds of hydrogen and helium, the primordial elements forged in the Big Bang. These clouds were the raw material from which everything else would eventually be built. Drifting aimlessly through the void, these clouds seemed to hold no promise of the brilliant future that awaited them. But it wasn't perfectly uniform. Even in this seemingly featureless expanse, subtle differences existed. Tiny ripples, minuscule fluctuations in density, seeded the future, setting the stage for the formation of the first stars and galaxies. Gravity, the relentless architect of the cosmos, began to pull denser regions together ever so slowly. Slowly gathering gas into clumps, these regions became increasingly dense, attracting more and more matter. Over millions of years, these clouds collapsed under their own immense weight, the relentless pull of gravity compressing them ever tighter. As the gas compressed, it began heating up, the core of each cloud glowing faintly with the energy of gravitational collapse. When the core reached a staggering 10 million degrees, something extraordinary happened. Nuclear fusion ignited in the heart of the cloud, a self-sustaining reaction that would forever change the universe. A star was born, the first light in an age of darkness. The first in the entire universe, a beacon of hope in the vast cosmic void. This was the cosmic dawn, the moment when the universe began to awaken from its long slumber. The end of the Dark Ages, a pivotal moment in the history of everything. The first stars were giants, unlike anything we see today. Burning incredibly hot and bright, they flooded the surrounding space with intense radiation. But living short, violent lives, they were destined for spectacular ends. Their light rayonized the surrounding gas, stripping electrons from atoms and transforming the universe once again, clearing the cosmic fog that had permeated the universe since the Big Bang. Pockets of light appeared, illuminating the darkness and heralding a new era. Spreading like beacons in the darkness, these first stars paved the way for the formation of galaxies and the complex structures we see today. The universe was no longer uniform, it was beginning to differentiate itself. It was becoming a place of structure, of light and shadow, of increasing complexity and beauty. These first stars forged heavier elements in their cores through the process of stellar nucleosynthesis. Carbon, oxygen, iron. The very elements that make up planets and life as we know it. Making future planets and life possible, they seeded the universe with the building blocks of complexity. Their brief, brilliant lives were a necessary sacrifice, a cosmic act of creation. For complexity to come, these stars had to live and die, scattering their enriched material throughout the cosmos. Picture the darkness, the absolute absence of light. Then a single point of light appears, a tiny spark in the vast emptiness. Then another ignites, joining the first in illuminating the void, and another until the darkness begins to recede. The universe was waking up, stretching and yawning as it emerged from its long, dark sleep. The first stars had switched on the lights, signaling the dawn of a new cosmic era. The first stars soon gathered into larger structures. Gravity pulled stars, gas, and dark matter into clumpy, chaotic galaxies. These early galaxies collided and merged, growing larger and more complex. Each collision triggered bursts of star formation, millions of new stars born at once. At their centers, the most massive stars collapsed into black holes. As galaxies merged, so did their black holes, growing into supermassive giants. Feeding on gas and stars, these black holes blazed as quasars, beacons from the young universe. Over billions of years, galaxies settled into familiar shapes, spirals like our Milky Way, and vast ellipticals. The universe became a cosmic web, galaxy clusters separated by immense voids. The simple, uniform cosmos was gone, replaced by a tapestry of light and structure. Imagine countless islands of light, each a galaxy with billions of stars drifting in the cosmic ocean. The universe was now a grand city of galaxies. The age of galaxies had begun. Within galaxies, the cycle of stellar life and death continued. Massive stars lived fast, died young and exploded as supernovae seeding space with heavy elements. These elements formed beautiful nebulae stellar nurseries for new stars. Gravity pulled enriched gas into spinning disks, birthing new stars and, for the first time, planets. In the inner disk, rocky planets formed from dust and debris. Farther out, gas giants grew, capturing hydrogen and helium. Solar systems emerged from chaos-ordered worlds orbiting stable stars. Our Sun and Earth are products of this cosmic recycling. The death of one star provided the ingredients for the birth of another and its planets. Out of stardust, new worlds were born. Our story narrows from the vast expanse of the cosmos to a quiet, unremarkable spiral arm of the Milky Way galaxy, a region far from the galactic center. About 4.6 billion years ago, In this quiet corner of the universe, a cloud of stardust, the remnants of long-dead stars collapsed under its own gravity. This collapse ignited a new star, our sun, the center of what would become our solar system. In the swirling disk of gas and dust around it, a chaotic dance of particles began. From this cosmic debris, Earth was born, a world in its infancy. It settled into its place, the third rocky planet from the sun, a position that would prove crucial. Early Earth was a molten, hostile world, a fiery landscape of volcanoes and lava flows. It was constantly bombarded by asteroids, remnants from the solar system's formation. A colossal impact, a cataclysmic event formed the moon, our celestial companion. This event had a profound effect, stabilizing Earth's axial tilt and consequently its climate. As Earth gradually cooled over millions of years, water vapor in the atmosphere began to condense, forming clouds. Rain fell for eons, filling the first oceans, creating a water world. Beneath the waves in the dark and warm primordial waters, sheltered from the harsh radiation of the early sun, something extraordinary, something truly unique, was about to happen. Earth, a pale blue dot suspended in the vastness of space, was just one of countless worlds orbiting distant stars, a tiny speck in the grand cosmic tapestry. Yet, it had the right ingredients, a fortunate combination of factors. Abundant water, the solvent of life, a stable orbit within the sun's habitable zone, a protective magnetic field deflecting harmful solar radiation, and the presence of carbon-based molecules, the building blocks of life. The universe, in its infinite wisdom, had created a cradle, a nurturing environment. Now it waited patiently to see if anything would stir, if life would awaken within this cosmic haven. Look at our world, this precious planet, a small blue marble suspended in the black void, a testament to the improbable. It was a lonely outpost of warmth and potential in the vast, cold cosmic dark. Its future significance, its destiny, was not yet apparent to any observer, but it was on the verge of becoming something truly special, a living world. Life began simply, self-replicating molecules in Earth's oceans nearly 4 billion years ago. For billions of years, life remained microscopic. Then, a microbe discovered photosynthesis, releasing oxygen and transforming the planet. Oxygen enabled complex cells, then multicellular life. The Cambrian explosion brought a burst of diversity. Life moved from water to land. Plants, insects, amphibians, and reptiles followed. Dinosaurs ruled for millions of years until a cosmic impact ended their reign. Mammals rose, diversified, and one branch evolved larger brains, humans. In a blink of cosmic time, we developed language, art, science. For the first time, the universe became aware of itself. Through us, the cosmos reflects on its own beauty and mystery. We are the universe's consciousness, its way of knowing itself. Billions of years of evolution led to this moment of awareness. Which moment amazes you most? The first light, the first star, the first thought? Reflect on this journey. Our moment of consciousness is fleeting. The universe's story will continue long after we're gone. In billions of years, the Milky Way and Andromeda will merge, creating a new supergalaxy. But star formation is slowing. The universe's gas is running out. The last stars, dim red dwarfs, will burn for trillions of years, then fade. The cosmos will enter the degenerate era, filled with white dwarfs, neutron stars, and black holes. The universe will grow dark and cold, a graveyard of dead stars. Gravity will continue its work, drawing remnants together. Black holes will dominate, silent and invisible. Imagine a sky without stars, a universe falling into darkness. The great age of starlight will be over. Welcome to the black hole era. The last red dwarf has died. Only black holes remain. Galaxies are gone, their matter consumed or scattered. Black holes are the final structures, silent in the void, but even they are not eternal. Hawking radiation will slowly evaporate them. Over unimaginable timescales, black holes will vanish in faint pops of energy. The universe will become a diffuse, cold soup of particles near absolute zero. All structure and history erased. The cosmos will return to near-perfect uniformity, cold, dark, and empty. The great cosmic story will have reached its final chapter. This is the end, the heat death of the universe. No more change, no more evolution, no more time in any meaningful sense. Matter and energy are diluted to maximum entropy, a vast, cold, silent sea. The cosmic story is over. There is no more light, heat, or life. The arrow of time ceases. The universe simply is, a static, unchanging state that will persist for eternity. The great cosmic play has ended. The theater is empty, the lights are out. Is this tragic, or simply natural? The universe, like everything, has a life cycle. born in fire, dying in ice. We are a brief, beautiful moment in its long life, a spark in the darkness. To understand our place in this grand narrative is a profound gift. In this final silence, reflect on the journey, on the brief, improbable, and precious nature of this moment.